Hello. Um, so we are now ready to start our analysis of binary outcome. As I said, we are going to study the relationship between kid count and a binary dependent variable worked m. So there are four things we need to do from the full sample. The first job is to compute the probability of working women. So there are many ways to calculate the probability on stata, but the simplest way to do that in our analysis is to use mean. So simply I'm going to write it onto file. So let me write down binary dependent variable like worked m and full sample. I'm And then the first thing we have to do here is calculating the mean. So remember in binary variable, the probability of 1 equals to the expected value of the binary variable. So in this case, we are calculating the probability of working mothers. So that's equivalent to calculating the mean of worked m. Run this, and then you have this result. The mean command calculate the mean of this variable, and it shows 52.71194% of women are working. So this is how you can calculate the probability of working mothers, and this is standard error, right? And then the second thing, the first job is pretty easy, and second, regress. We are going to regress worked m on all covariates, and we are going to use robust option. And second regress, I'm going to regress worked m on kid count, and we are going to include other control variables like age, education, and race. To do that, like simple way is just to click, double click all the variables, all the control baseline control variables, and I'm going to copy and paste here. And finally, we have to use robust standard error option here, comma robust will will calculate the robust standard error. So run this, execute. Then you see a linear regression result. So a familiar form. And by the way, one variable was omitted because you cannot use the full set of dummy variables. So other race is excluded because you need to delete at least one dummy variables when there are a certain number of categories. So far so far nothing new, but we are going to now the third point number 3 is estimate the probing model. So we are going to use the probing model like a linear regression, use this as a dependent variable on all covariates. And you may use this command, but let me show you how to find the probit command. Statistics, binary outcome, probit regression. Logistic regression can do the same thing, pretty similar, but we are going to use probit. You may try logit, but we are going to use probit regression. Click that. And the command panel is similar to the regression command panel. Dependent variable we use is worked m. And independent variables include the type. You have to click once each. So click everything, all the basic set of variables, and just click OK. We are not going to use robust option here. It is possible, but nonlinear models have different formulas to calculate the standard errors, so we don't mind not using robust option here. Just click OK. Then it takes a little more time, a few more steps, and the result is pretty similar. This is a result of probit regression. The result looks pretty similar to the linear regression result. So you can interpret the results in the same way as you interpret the linear regression. And I'm going to copy the command to the file. Okay, so probit model is obtained, and our main interest lies in its effect of kids count on worked M, mother's working status. By the way, when you compare this with this, you see a huge difference. So in the linear regression model, it means that additional kid will decrease lower mother's working probability by 11.29%. That's how you can interpret this coefficient. But now suddenly in probit model, it becomes minus 30%, like nearly tripled. How can you interpret that? So the main problem is probit regression is nonlinear. So as I said in class, its coefficient means nothing. The magnitude of the coefficient means nothing. You cannot interpret this directly. You have to calculate marginal effects, which is what captures the effect of this variable on the dependent variable. So itself has no meaning directly. However, as you can see, if you compare all the other things, all the coefficients are pretty much similar, like similarly tripled, 3 times larger than the linear regression. But the signs are consistent, and in the same way it is dropped. So most of the coefficients are like larger than the linear regression, but means nothing. The scale of the coefficients are not important. So that means we have to have another step to calculate the marginal effect. That's the number 4. You have to calculate the marginal effect of kid count on worked M so that we can compare the effect of kid count on worked M between the probit model and the linear regression model. So now we just run probit model. We run probit model, and its results are now saved on the memory. If you run another regression, then the results will be gone. So for example, the results of linear regression, these results is deleted from the memory. It's not on the memory, but the most recent regression results are now still on the memory. We may use the memory, results on the memory to calculate something else. That is in post-estimation menu. So statistics, post-estimation, this menu collects all the possible things you can do using the results on the memory, like post-estimation. And here, marginal analysis. This is what we want. And the first thing, marginal effects. This is what we need to do now. Click. And so covariate. We want the covariate kid count. Effect of kid count on the dependent variable. Analysis is marginal effects, not means. Marginal effects. And you don't need to touch anything else. You may change this, but does not matter. I'm going to use the default and just click OK. OK. Then using this command, I will copy the command to file. So command itself is pretty simple. And by the way, again, this command should follow the result of the previous regression. So if you put it here, then the result will be different. So order is important in here. And now you see this is the marginal effect of kid count on mother's working status. So it's now pretty similar. 11.37% decreases if a woman has additional child. That is comparable to 11.29. So now you see in the OLS linear model and nonlinear model, the results are pretty much the same when you convert the nonlinear coefficient into the marginal effect. Okay, so far we have finished like a quarter of the analysis from the table. So we have done 1, 2, 3, 4, and so far what we have done will be included in here and here and here, right? So by the way, you don't need to do this. I'm not going to do this. Just to column 4 will be dropped. Column 6 will be dropped. So just 1, 2, 3. Those are also 1. Excuse me. 1. Put it this way. We have done this. We have done this. The numbers are quite different. Maybe there are some other things not explained in the textbook. So we have calculated those 3 numbers. In the next video, we are going to calculate here, here, here. So see you in the next video.